Good morning, everyone, and welcome to the third and final part of our hosted presentation dealing with subsurface drip for wastewater dispersal. Today is September the 13th, and in the first part we looked at reviewing the design from a regulator standpoint. In the second part we looked at installation techniques and red flags that regulators need to be aware of. Today we're going to be looking at the review of the operation and maintenance plan. Most advanced systems in most jurisdictions require the submission of an O&M plan as part of the permitting process. That might be different in your area, but in most of our areas in Michigan that is required. I am your moderator for the day, and I will be working in the background handling the questions and any technical issues that I can actually handle. I am not a Blackboard guru as far as the tech part of it, but I can help with most of your issues. My name is Dendra Best. I'm the Executive Director of WasteWater Education. We're a public nonprofit entity. We're based in Northwest Michigan, but we serve all the states in the U.S. and obviously some overseas as well. I'm not sure if we have our overseas attendee here today, but I will check that later. Remind you that we are seeking funding to provide closed captioning services for all of our presentations. But in the interim, if you do need a text transcript to go into an e-reader or a translator, you can request one directly from me, and my email is right there. And here in a minute, I will put that right into the chat window. And here you are. A reminder from the legal standpoint that WasteWater Education hosts these events as a public forum for the free exchange of ideas and information. We are sincere in our desire to form partnerships and to create a network of resources. But our presentation today should not be construed as an endorsement or an advertisement for any particular technology or any particular vendor. But that being said, we are deeply appreciative to Geoflow for putting together this presentation today, and they are major underwriter of this event so that we can provide it at no charge for regulators. However, if you're not a regulatory agent and you are representing an engineer in an engineering firm, we are requesting a small free will donation. Hopefully you will be as thrilled with this presentation that your donation will reflect that. I have a couple of introductions here to get people used to how the screen works and to the sound of how your audio works so you can adjust it if you need to. This slide should not come as any surprise to anyone on this call today. We showed a slide yesterday of the Drought Monitor, which shows that still the middle third of the country is in severe to extreme to moderate drought. All the counties in Michigan have been declared a drought disaster area. It has wreaked havoc on our agriculture and our economy. And because our motto this year that we've included in our strategic plan is "It's all connected," we pull all of the various factors together: water use, the cost of supplying water, the energy cost of supplying water. We are an EPA WaterSense partner, so we are deeply concerned with the amount of electricity that is needed to generate transmission and treatment for water. And obviously, the cost in water, which is needed to generate electricity. We're talking today about drip dispersal systems, and this is particularly relevant for us as an EPA WaterSense partner because, as you see from this slide here, we were experiencing extreme heat through most of the country this year, and this is increasing the capacity demand upon utilities and increasing the capacity demand upon water systems themselves. And Again, this is a staggering figure. 29 billion gallons of water are used in homes by in the U.S. And of that, 30% is devoted to outdoor water use. And some of you are calling in today from the Deep South and the Southwest, and you know all about the issue of dry climate. And if we can tie our wastewater systems into our demand for outdoor water use, then why in the heck not do it? Up to 50% of water that is applied from irrigation is lost to wind and evaporation. Improper design, installation of maintenance. This is critical to the topic that we're covering in these 3 sessions. And of course, our preaching to the choir here, but we often have to preach to the general public and elected officials that wastewater systems are not the problem. All of us in the wastewater professions are part of the solution. And if we didn't have good sanitation in this country, then we probably would be back to the average life expectancy that we were experiencing at the turn of the century, where we have actually doubled the life expectancy. And a good part of that is because of the development and the enhancement of water and wastewater systems. Again, quick slide here from yesterday of the Drought Monitor. This was as of September the 4th. And you can locate this service at, and I will put the URL into the chat window here. Much shorter one is drought.gov. And our closing slide before I hand off to Rodney here is an emphasis of what we were just talking about. Those of us in the wastewater business are not in the business of discharging filth to the environment and hoping it goes away and disappears. We're in the business of providing clean water back into the environment so it returns to us as part of the water cycle. And unfortunately, as we talked about yesterday, this is something we continually need to promote and advocate for to both the general public and elected officials. So with that, I am going to hand over to our presenter, Rodney Ruskin. And Rodney, take it away.
Well, good morning, everybody. How is the sound? Is that better than yesterday? At least I hope it is.
Yeah, much better, Rodney. Thank you.
Okay. Well, let's hope everybody else has got the same feedback. Maybe by the 5th or 6th time I do this, we'll get it right. Okay. Obviously, when you're dealing with effluent and you're dealing with disposal, it's totally different than dealing with irrigation. Irrigation systems are generally using clean water and generally running when the plants need the water. And it's a completely different situation than operating every single day and virtually the same volume of water going through, depending on the season or the usage, but in the typical home, the same volume of water going through every day. Okay. Yesterday, I got a little confused on this slide, so just to rectify what I said or clarify what I said. This about these 3 gauges up here. Why are there 3 gauges? Well, the 1 gauge, it doesn't matter which one, but let's say this one and this one are across the filter, so they give you the pressure drop across the filter. And the one on the outlet of the filter, of course, is giving you the pressure out to the field, which is now going through a flow meter. This other gauge is connected to the return line, this line here that's coming back from the field, and that is hooked in here somewhere that we can't see. And so this is telling us, when you look at the pressure here and the pressure there, it is telling you the pressure drop from there through the field, from there through the field, round and back. So that gives us the pressure drop in the field. So if that's either too higher or lower than design or higher than when it's set up, then you know that something's gone wrong. So that gives you the use of the 3. Do you really need this while you've got a flow meter? Well, I don't suppose it does any harm. You can look at that very quickly and without having to look at the flow meter, but it is also redundant to some degree in this particular case with the flow meter. If you don't have a flow meter, then it's very useful, because obviously if the pressure drop is less than expected, then there's a leak somewhere, and if the pressure drop is higher than expected, then there's a blockage somewhere, so that gives you that signal straight away. Okay, we'll go back to this standard drawing of a zone and talk about where we have to worry about the maintenance. All right, here we have a pump tank. Now, inevitably, you're going to get build-up of solid material in the bottom of the pump tank. Periodically, the pump tank has to be pumped. Now, this again depends on the quality of your pre-treatment, and which again depends, the quality of your pre-treatment frequently depends upon the quality of the maintenance of your pre-treatment. Anyway, I'm not going to go into maintenance of pre-treatment, but this is something that has to be watched. And the pump is usually at least 6 inches off the ground, but sooner or later you're going to get an excess of solids coming through the pump. Here in this particular drawing we've got floats, 4 floats. There are other systems with transducers of a different type, various types of transducers, or they've got systems where you have sound or light bouncing off the top of the water to measure the depth and to send the signal as to when to go on and off. But floats, I think, still cover probably 90% of the systems in the marketplace. And one of the problems with floats is they're not 100% reliable, so they do get tangled up, and they're mechanical. So it's a good idea to pull the floats every 6 months and just check that everything's working correctly and put them back in again. From there we go through the filter system. And the filter system can vary, as we discussed, at different types of filters. But the filters, again, I believe every 6 months should be taken apart, cleaned, and put back together again. With some filters, like a low-cost screen filter, the contractor will keep clean screens in the back of his truck and just take out the dirty screen and put in a clean screen and take the dirty one back to the shop to clean. In the case of discs, he might have to take them apart and clean them and put them back in, but they should be checked, because things do go wrong. Even though everything seems to be working fine, you do get upsets. Something happens in the home, something happens, treatment plants break down, they have hiccups, all sorts of things go wrong. Incidentally, one of the things that, you're just mentioning it, that does frequently go wrong with treatment plants, and I say frequently, I mean frequently when there's thousands of plants out there, is somebody in the home goes on to chemotherapy. And that, of course, their urine carries the chemical through into the septic tank and kills the bacteria. And we have an upset. And that is quite a common problem. Not very common, but quite a common problem. So that can be a question if you're having a system that's persistently giving trouble, that you might want to ask. Okay, then again, you've got your flush valves. Probably once a year it's frequent enough to take the flush valve apart and just check that there's no dirt under the rubber, and you've got both your flush valves. Okay. Then you've got your air vacuum relief valves up here. You can screw off the top of these air vacuum relief valves and clean them out. Make sure that that the ball is floating up and down freely. You do get insects, often spiders, that seem to like to crawl inside there and build their nests. That seems to be quite a frequent problem. And then, of course, they stop the valve from seating properly and you get leakage. So those need to be cleaned every 6 months. And then the next thing is to walk the field. We'll go through this as we go through the slides. We will repeat it. Okay, roots are generally not a problem. My company gives a 15-year warranty against root intrusion, and I believe our competitors give a 10-year warranty against root intrusion. It can happen that in installing or cuts through a main root and you get strangulation. Well, I've been in the business, and I'm talking about millions of, thousands of miles of subsurface driven agriculture, where they planted in orchards, and I've seen that once. I've only seen strangulation once, so it's not a problem I think we need to worry about. And even if you do get strangulation, there's only going to be one lateral, and that lateral will be supplied from the flush side. The flush manifold will send the water back towards the blockage anyway, so it's not, it wouldn't even be, I don't think anybody would even know it's there. Okay, let's go on to the next slide. Okay, this shows you a golf course tee under construction, so you can see the drip line is only about 6 inches under the ground typically. If when you're inspecting, you find that there's a flood of water here, it's presumed a gopher's gone through, or something like that, or somebody has stuck a tent peg into it for some reason, or something like that. It's comparatively simple to dig it up 6 inches down and put in a coupling and repair the damage. We don't find gopher damage a serious issue. It does, and again, it does happen. Gophers generally don't like wet soil. So when we've had gopher damage, it's been before the system's been switched on. You'll sometimes have the system go in before the house is occupied, or sometimes you'll have the house, it's a single-family homes, standing empty for a long time. And if there's a dry season, the soil will dry out, and then gopher strikes are much more likely than when the system's operating. When the system's operating, as I said, the gophers don't like the wet soil and stay away.
Rodney, can I ask a quick question on that slide?
Sure.
How would you do O&M to be sure that lines were clear? How would, I know we're going to be talking about flushing and cleaning later on in the presentation, but let's just suppose here that we have a damaged drip line. How would you build that into an O&M plan? How would you build in an evaluation that the drip line system, particularly if it's looped, is working? And what would you expect to see in an O&M plan for that?
If you can have real damage, in other words, a hole in the drip line, you'll see it straight away. The ground will be wet, so you won't have any trouble seeing that. And also, you have either you have a flow meter or you have a flow totalizer. So all you have to do is run the system, and if it's a totalizer, just take out your stopwatch and time it for a minute and see that the flow per minute is as per design. And if it's lower than design, you've got blockage, and if it's higher than design, you've got a leak somewhere. That's fairly standard.
Okay. Thank you.
It doesn't mean that people do it. The real problem with maintenance isn't what the regulator can do, which is sort of discuss what should be done, is to make sure it is done. And of course, this is a different discussion. How do you discipline your maintenance people to see that they do what they're meant to do?
Just a quick question then to the room. I've noticed a couple of people need to adjust their volume levels. It's fine for most of us, but just a quick question for the room. all of you here, how many of you do require an O&M plan as part of your permitting process? If you would use your green check or your red X, that would be great. Most everyone is coming back in. Cindy, not. Yes, yes, a couple of comments coming back in. And also in the chat window then, would you let me know what the frequency is that you require reporting back? You know, Rodney is recommending 6-month O&M visits. What do you require? So, Rodney, I'm seeing a lot of annual reporting coming back in. How do you feel about that?
Well, I mean, if I had the ability to enforce it, I'll say 6 months is better than annually. I mean, but a lot of people are annual, and a lot of you see there's no reporting required at all. And I mean, we get phone calls from people, from homeowners, who've got our phone number from seeing it on the controller and saying, hey, my system isn't working, can you help me? And then you sort of start asking questions, and it was installed 5 years ago and nobody's ever looked at it. Mm-hmm. Well, then we have to start finding who put the system in and get them to go out and look at it. So this happens. But again, I think in Washington there's one county that, if I'm not mistaken, Richard can answer that, but I think there's one county that actually requires every system to be connected online by wireless connection, and it's continuously, the data is continuously available at the office, on all the systems that are in the county.
So
there's no limit.
And again, another question for the room. Yeah, another question for the room, and then I see I have a hand raised from Larry, and I'll ask Larry here in a minute to turn his microphone on and talk about this. The O&M report that comes back in your O&M requirement as part of the design, what do most people here require as the period between an O&M visit to the site? They may be required to report back to you, the permitting agent, on an annual basis, but included in that is the requirement that they must have an O&M visit to the system at a regular period. And while you're all putting that into the chat window, Larry, if you have a microphone, go ahead and turn it on.
There's no way to turn it on.
Hi. Good morning.
Morning.
Is this Larry or is this Scott?
This is Larry. Scott's not here today.
Okay, go ahead, Larry. Just to remind everybody from who was here yesterday, Northwest Michigan Health Department have a number of subsurface drip systems, and we talked about that yesterday and looked at one in particular. And Larry is one of the lead sanitarians with that department. Go ahead.
Okay, I just want to let you know that I didn't get, my green arrow didn't get clicked, but we do require an operation maintenance plan as part of our permit requirements. And we require an operating permit, and that's one of the requirements for that.
Okay, what interval do you have between O&M visits?
That varies. You might ask Dan. Dan has a few more of them than I do. You might ask him. I think it's 6 months.
Yeah. I see Dan is responding. Dan doesn't have a microphone, but okay, if you would turn off your microphone and we will see the questions coming in and move on here. I'm looking here, Kemper, who is in Virginia, is requiring annual. Mary Clark, who's in Vermont, the reporting is tied to the system. Grand Traverse is once a year. Mary Clark has confirmed hers that they require twice during the first year, annual after that. So the cure, and Janice Hure, who's with Michigan Department of Environmental Quality, is requiring them to write the O&M manual. That's brilliant. But there is no assurance that they are following the manual. Okay, well, we'll gloss over that. Go ahead, Rodney. Go ahead.
Well, this is enforcement is the issue. Enforcement is the issue. I mean, and you know, the audience are regulators. I'll sort of leave it to you to discuss, because it can be very frustrating sometimes as a manufacturer when you get calls that have got nothing to do with us, and purely, absolutely that complete neglect has caused, whatever problems there are. Usually they're fixable. Happily, they're usually fixable, but it's very frustrating, and I'm sure that you, as regulators, get it, every now and then as well. And I don't think, and I mean, I don't have the statistics, but I don't think it's limited to any one part of the country. I think it's just the nature of the industry. And I think the same treatment plant manufacturers, I think, will tell you exactly the same thing.
Yeah.
Okay. Well, this part, the connections very seldomly give you any trouble. That is not of any consequence. The manifold connections scarcely give you any trouble. If you have to replace an entire drip line, which is very unlikely, it's easy enough if you dig it up to cut it here, and if you cut it there and take a coupling like this, and you can put the coupling in there and connect up a new drip line if necessary. And again, that sort of thing is extremely infrequent. But it's not difficult. It's not difficult to do as necessary. Okay, now again, the emitters, of course, can plug. They can plug with dirt coming through the filter. We do have situations, and I'm sure quite a few people in the room have run into it, in which the filter plugs up for one reason or the other, the upset of the treatment plants, or whatever reason, or some change in the what's going on in the home or property, and the filter plugs up. Then either the homeowner comes out and starts looking around and says, "Oh, this is it. This thing's plugged up," and takes out the filter element. And then puts it back together again. Oh, now it works beautifully without the filter element. And this happens quite frequently. I mean, sizzling not once a month, but a couple of times a year we run into this. And then, of course, there's a good risk that you're going to plug up the dripper itself, and with biological slime. Now, even though there is an antibacterial in the dripper, as I mentioned yesterday, ours is tributyl tinmaleate, and our competitors is an arsenic compound, and it certainly does a lot to prevent the biological mat. But if you put enough through, it's going to just plug it up with dead bacteria. Fortunately, that type of problem is usually soluble with chlorine and acid. If it happens, chlorine and acid will usually clean it up. It's, as I said, it's not frequent, but it does happen. The other risk is, as we spoke about yesterday, is that vacuum, because of non-operative air vacuum relief valves is the usual reason, vacuum can suck sand back into the dripper and actually plug up the exit hole. Now, again, usually if you switch the system on and off repeatedly, giving it a, switch it on with a short burst and switch it off, it will dislodge it and begin to operate again. If it doesn't, if it's plugged up forever, well, then I did talk about replacing the line, well, as might be necessary. Now, again, I mean, in all the tens of thousands of systems that my company's been involved with over the, since 1990, so it's the last 22 years, I can't even think of a handful where the drip line's had to be abandoned. But it is, if necessary, you can replace it and reconnect it to the manifolds.
Rodney, there is a quick question in the chat window from Janice, and she said, do you have a recommended VOD limit for effluent to prevent the excuse me, slide buildup? Higher VODs would require pre-treatment, and I think we talked about that yesterday, but go ahead and address that, would you?
No, we have no VOD limit. We've had, wait for it, VODs of 1,000 milligrams per liter deliberately in a research project where we took effluent directly out of a dairy lagoon where the VODs, as I said, were up to over 1,000 milligrams a liter, and used it to grow alfalfa. This was at the Fresno State University in the Center of Irrigation Technology. And the drip line worked perfectly. There was no problem at all. It was correctly filtered. And, again, correctly flushed. The VOD is not the problem. The problem with VOD is the soil. Now, in that particular case, we did have biological build-up in the soil because the soil couldn't handle the 1,000 milligrams per liter over more than about, well, the first year it was working fine, but in the second year we began to get slime in the soil. But which is inevitable. I mean, I think anybody that's worked with a conventional septic tank has an idea. Septic tank and drain field, has an idea how this happens. But no, we have no limit as far as we're concerned. If our competitors do, you need to ask them. Our product is a little different from our competitors, and I'm not going to make this a sales spiel, but you can talk to them about it.
Rodney, what was the name of that university again, the case study? I didn't quite catch up.
Fresno State University.
Is that
Fresno State?
Is that case?
California.
Yeah. Is that case study available?
No, it's not KSU.
Yeah, is that case study published?
Yes, actually, I think I'm 90% sure. I'm 90% sure it's on our website.
Okay. All right. Thank you.
But that is animal waste, which is a totally. We are involved in animal waste, but it's a totally different situation than human waste for obvious reasons. I mean, we're dealing with very high VODs and totally different type of problem. Okay. This is one of the most common filters you'll find in single-family homes, which is a screen, which is inserted in here. The screen's in here. Okay. We recommend either a solenoid valve here, which can get opened at every cycle, or alternatively, you can have a normal ball valve and just crack it open a fraction so that when our system's operating, it is continuously flushing through the center. And again, I would recommend every 6 months. And sure, I mean, if everything works right, it can often go 5 years, but I would still recommend that every 6 months this get taken out. And this is one of those cheap ones where they can take it back and clean it at the shop and put a clean one in. And again, my recommendation is every 6 months, but will it take it last a year? Yeah, if everything works right, it will last a year. Will it last 5 years? Well, sometimes we get that call after 5 years because nobody's never taken it apart since day one. All right, this is another headworks. This is a typical headworks system with disc filters. Here's a disc filter, 2 disc filters, one backwashing the other. And these systems can run for a long time because they backwash one another efficiently. But again, I would recommend biannual, but at least annually, take them apart. This purple head will screw off and you can pull the discs out, clean them, and put them back in again. And here you've got your solenoid valves. Now again, these should be taken apart and make sure that there's no debris under the diaphragms. Okay. As I say, I mean, you know, we've seen that, you know, from the feedback here, and of course, you know, a lot of people only require annual treatment. And this is only a question of risk aversion. I mean, you know, this whole discussion, any engineering decision is a trade-off of risk. I mean, it's the same as your car. You get your car, get the oil changed every 7,500 miles, as I do, or every 5,000 miles, as other people do, or even more frequently. I mean, and it's absolutely a risk decision. Air vacuum relief valves, this will screw off, and it must be screwed off, and again, more frequently the better. And check that the ball is clean, that the basin is clean in here for the ball to move up and down. This is a Schrader valve here, where you can put on a pressure gauge, and you can measure the pressure in the manifold, and that's by either the flush or the supply manifold. Is either. They both look the same. Okay, this is a newer air vacuum relief valve. This also comes with a Schrader valve. This one isn't drawn with it, but this is tapped. It's tapped here, and the Schrader valve is fitted there. And again, we like this one because you can, if you want to flush the whole system, if you want to flush the manifolds, you can unscrew this. You can unscrew this part here, take it off, take out the ball, remove it, screw this back on again, and then screw a hose on there, switch on the system, and you can then take the flush from the system through a hose to wherever you want to take it, connect it in a drum, or take it back if you're close enough to the pump tank or the treatment plant, and flush out the manifolds. Okay. So here we've got check air relief valves for proper function and no leaks. Check operating pressure in the field, which you can do either here or back at the headworks, depending on how the headworks are set. And field flush each zone for removal of fines and slime buildup. Okay, and if you want to flush the supply manifold and return manifold, you can do it that way. But you don't need to do it.
Rodney, there's a question from Kemper. How does the illustrate valve release the vacuum?
Okay, here's the ball. You see the ball there. Okay, so under pressure that gets pushed up and the air gets pumped out. And then when you switch off, this comes back down, and there is a relief slit in the valve here, which you actually can't see in the seat, that allows the air to come back around there and back down here. Well, that isn't quite intelligent, is it?
It sounded pretty intelligent to me.
It's not. It needs a seat. It needs a seat up here as well, because under pressure that will get pushed up, and it needs to have a seat up at the top here as well. So obviously the ball moves up here and has to seat up here. I haven't taken one of these apart for a long time, but it needs to seat up there. When I leave you, I'll go and take one apart and check if there is a seal up there as well, but there has to be. And then when there's a vacuum, it will fall back down again. But it has to move up under pressure and down under vacuum.
And there's a follow-up from Kemper on that. He is asking, wouldn't it release water under pressure as well?
Well, if it's going to seat under pressure here, then it won't release water because that will be seated here, and then the water won't be able to get through. It's only under vacuum that it will fall down.
No.
But I don't see how under vacuum, if it's fall down and being pulled down, if it's sealing here, it's not going to let the air back. It's not going to let the air in, so it has to allow the air back in here through a slit. The ball has to move up to let the air out. Okay, but under water pressure, it's going to stay up. So under vacuum, it falls down and then has to have a leak here to let the water flow out. Correct? There has to be, to let the air in, there has to be a route through there when it's sucked, when there's a vacuum sucking the ball down. So I need to look and see if the design of that seat to see how it works. I quite honestly haven't looked at it.
I see. We'll do that in the follow-up then.
Yeah, sorry.
Okay, moving on then.
Here's the next one. But there has to be a bleed. There has to be a bleed at that point to allow air back in. Okay, your controllers. Now controllers are critical. You'll get pretty popular, particularly in Washington, controllers with continuous online wireless connection, usually wireless, sometimes telephone lines connection back to the manufacturer of the treatment plant with continuous monitoring. And this is completely practical. It works. It's purely an economic decision. Now, if I'm not mistaken, and Richard Benson will know, I think there's a county in Washington that actually requires continuous wireless monitoring. But again, you'd better have wealthy people in your county before you're going to require that. As I said, it's the capital cost versus the extremely good maintenance and monitoring. Okay, so your controllers are going to vary in sophistication. They must, as a minimum, do automatic flushing of the field and the filter. Your filters have to be flushed periodically, your field has to be flushed periodically, so that must be a minimum. Unless, of course, you're doing continuous flush, which again, as I mentioned, I think on the first day, is quite popular in Washington. So if you're doing continuous flush, you don't need to have this automatic flushing. But again, as I argued, it's a trade-off between capital investment and operating cost. You need to time dose your field. Now that is critical. Demand dosing is not a good idea with drip. In fact, it is a very bad idea with drip. If you can remember, those who were here, I had that slide showing how the water moves away from the dripper when it's giving short doses. The maximum dose you'll ever want, or ever likely to want, is 15 minutes of dose time. So say you've got a 1 gallon dripper an hour, you're putting out 15 minutes, you're putting out 1/4 of a gallon. And then letting it rest. So you can just think of 1/4 of a gallon as a maximum, and then letting it rest so that the anaerobic bacteria that are coming through with the effluent can be taken up by the aerobic bacteria in the soil and be ready by the next dose for Dosing is spelt wrong there, isn't it? And be ready for the next dose for the to take more anaerobic bacteria without building up a biological net. But time dosing is essential. You want an event counter so that when there's something, so when you come back you can check how often the pump went on, the amount of pump time, if the high water alarm went off, how often it went off, and you can check the record of what happened. Controllers vary. There's PLCs, programmable logical controllers, that are easy programming, can store a lot of data, can be connected up to telephone lines or to wireless services to send out information automatically. Or the alternative is at the bottom end are boards. And boards are much lower in cost, and basically lower in cost, but they don't have that versatility. They're both used, and I'm not going to get into an argument as to why one obviously is better than the other in the point of view of understanding what's going on and following what's going on. But on the other hand, is it worth the cost? Is it worth the expense? And, you know, again, we all face that situation. I'm sure some of the people in the room are in areas where the sort of minimum price of a home is $500,000, and other people are in counties where the maximum price of a home might be $200,000. So you're dealing with totally different situations, which I understand, and you just have to. It's necessary to cater to the needs of your community, which of course is the situation that you all face as regulators. Setting up the controller. Okay, the soil type is critical. The heavier the soil, the shorter the pulse, the shorter the time. So you might, in a really good soil, you might run the system, say the system's got to run for 2 hours to get the amount of effluent out, get out the amount of effluent, sorry. That 2 hours in the case of a good alluvial soil, you might run for 15 minutes a time, and which means you run 8 times a day, once every 3 hours. On a very heavy soil, you might bring it down to half the time, say 7 minutes, 7.5 minutes to make it easy, and run 16 times through the day, which is, I think, every 1.5 hours. So,
Rodney, there's a quick question here about control panels, but we have a couple of slides coming up here in a minute, Mary, so we'll hold that question just for a couple of slides if you don't mind. Go ahead, Rodney.
Okay, I'll try and, yes, I will try and pay attention to that. And again, I'm trying to avoid trade names, but I think this particularly applies to Arenco, who build for their Arenco treatment plants, who sometimes combine the drip with their control panel. And Arenco, incidentally, build a lot of our panels for us under our name, but they build a lot of our panels for us. So there's no commercial conflict in this discussion, but yes, it can be a difficult discussion. I'll get to it. Okay. And as Dendra has highlighted what I was saying, 6 to 24 doses for 24 hours, 5 to 15 minutes typically. Okay. Now, again, some regulators in some states and some counties don't allow override timers. They don't allow 4 floats. We generally recommend 4 floats. The bottom float is the emergency off so you don't burn out the pump. So if that bottom floats down, it's just the pump protection float, it's nothing else. So there's no way the pump can go on if there's no water in the tank. The second float from the bottom is the pump enable. So if that's down, the pump won't go on. If it's up, the pump is able to go on. And then if the timer says pump on, the pump will go on. And when the timer says pump off, the pump will go off. The next level is what we call an override timer level. And when that goes on, it means that the tank is filling up more than we like. The tank isn't at the top yet. It's not full to the top, but it's close to the top. And unless we do something, the alarm's going to go off. And so to prevent that, if it's a comparatively minor problem, that timer, with the way we usually recommend this program, cuts the off time in half. So take that first example when I said we're running once every 3 hours for 15 minutes, then it will run every hour and a half for 15 minutes until that float drops. And that reduces the incidence in which the top float goes off, and when the top float goes off, the alarm goes off. And of course, if you're connected by wireless to a central station, then the alarm will go off in the central station, and the maintenance people will know that something's gone wrong. Or it will go off in the homeowner's bedroom, as if you remember my comment about the home in Malibu, and the homeowner will have the alarm going and will go into a panic and won't know what to do about it, and will start flaming. So that override timer is useful. It reduces the incidence of which the alarm goes off, but if something seriously wrong, the alarm will still go off. So anyway, I leave it to the regulators to decide whether they will allow them or not. As I said, some states or counties don't allow them. Most do. Most systems that go in with the four floats. And generally, if people come to us, we will recommend the 4-float system, and the controller set up to do that. All right, the controller is a monitoring system as well. And here we have a PLC. This is a Siemens PLC. And they are very popular. They are very easy to program, and they keep an enormous amount of data. And over the years, their cost has dropped. They used to be very expensive, and over the years they have dropped. And here we have a panel, and I think this is a board panel, if I'm not mistaken. Yes, here is a board. That is a board in the panel. If I'm not mistaken, that's the board. And now again, depending on the complication of the board, you can do quite a lot with a board, but a PLC is, as I said, far more flexible and generally can store much more data. Okay, monitoring allows evaluations. Okay. Today, the PLCs can be set up so that each zone can get a different time, which was one problem we did have with PLCs, that all zones were getting the same amount of time, and now they can be set up with each zone getting a different length of time, because you might find that one zone, for some reason or other, has a different soil and different type of soil, and you want to vary the time according to the zone. Okay. Okay, I think we've covered everything. Telemetry and recordings. Okay. And there's no end to the limit of sophistication. You can go, and on large systems, municipal systems, of course, they get very, very sophisticated.
Okay, Rodney, this is probably a good place to answer Mary Clark's question about whether
Yes.
the pre-treatment system and the drip should be on the same control panel.
Okay. All right. Now, there's no reason that they can't be on the same control panel if that control panel is set up to do all the functions that the drip panel requires. Sometimes people might take a control panel for a treatment plant and add on limited pieces, and then of course we don't get the control and the collection of data that we'd like to see. So this is absolutely completely dependent upon the person that's building the panel and how much attention they pay to what should go on the panel to control the drip. We have known panels that have been designed in a manner that we would recommend, where you end up with a demand dosing situation in which where you take the effluent directly from the treatment plant and pump it straight into the drip system, and you rely upon the operating control of the treatment plant and the flow of the treatment plant to determine the flow into the drip system. And this, of course, is dangerous, because if something goes wrong with the treatment plant, it is going to end up with excess flow going into the drip field. But if you go into a separate pump with a separate pump and run the separate pump with a separate pump tank and run it from the same controller, there's absolutely no problem whatsoever if it's set up correctly. But you can't do it with one pump, which is, I think, might be the question Mary Clark's really asking. I mean, if it's one pump, I don't like it. If it's two pumps and it's the controller set up to do the same functions, why not? There's no reason to have to. And in large systems, this very frequently is done with one very large custom-built control panel. Okay, so our options are printed circuit boards, which, as I said, are generally low cost. The PLCs, which are widely sold, that we spoke about. And here we've got a hybrid, which is a PLC and a hybrid with a board, which is often an economic decision for a larger system, where you'll have part of the system operated with a printed circuit board, and you've got the PLC monitoring and picking up all the essential data. And this keeps down the cost of the PLC instead of having a larger system. And these are generally custom built. I don't know anybody that offers this as a standard unit. We certainly don't, and I don't know anybody in the marketplace that I can think of that does. But I might be wrong. I mean, there's a lot of things go on in the marketplace that I don't know about. The large country.
Can we go back to that previous slide for a minute?
Sure.
The point that we cover occasionally when we do safety workshops for service providers is if they come out to inspect one of these panels, or that's part of their jurisdiction is to go out and check this, is to make sure the darn things are watertight, and that the last thing you want to do is open that up and find corrosion and insects and things that have dragged bits of vegetation inside that panel. So just a point from our experience is that, particularly if it's a built-in place panel, is to make sure that the thing is located somewhere that it's going to be fairly weatherproof.
Good. I see Mary Clark has said New Jersey requires a system integrator between the IA, I presume that's the treatment plant, and the drip. What do you mean by a system integrator, Mary? We'll wait. When your reply comes back, do you mean a person or do you mean a piece of equipment? Oh, you mean, okay, I have an idea, you mean a person. Usually it's one person. Okay, anyway, that's usually the same. No. Oh, absolutely. I mean, I don't know. We very seldomly have people not doing that. In other words, it's very, very seldom that somebody does the drip independently from the design, the design and O&M together. I think generally I see that too. I mean, it's hard for me to answer because I don't look for that, but typically they don't do the O&M, but they typically specify the OEM. I actually like design, build, maintain, and some people do that very efficiently and very effectively, and to be from our point of view, as the manufacturer, these are the people where we have the absolute least problem. Very, very seldomly does a design, build, maintain system cause a problem that they don't just solve themselves because they know the system themselves. And we very seldomly get calls from people who do that. So, of course, this is why we like it, because they have trouble-free, happy customers and happy suppliers. All right, there's various valves. Solenoid valves are most frequently used. Electrically actuated ball valves are sometimes used. Now, these can be very useful when you're draining a system under freezing conditions. These solenoid valves require a certain amount of back pressure in order for them to switch. So if the valve's normally closed, it needs a certain amount of back pressure for it to stay open. And once that back pressure drops below a certain level, and there's a couple of psi, the valve will close, and then the pipe might stay. The pipeline might stay full, and it can freeze. So if you're using a solenoid valve, and if you don't have a bleed to allow that last couple of feet of water to drain, you can put a bleed around it, or you can use an electric valve. Then an electric valve will stay open until the signal comes for it to close. So sometimes on freezing conditions, on the flush return, people will use an electric valve. They cost more, but again, it's cheaper than having a freezing situation, and some engineers prefer it to putting a bleed around the valve so that it is bleeding back all the time, irrespective of whether the valve's open or closed. Then, of course, index valves are used between zones to go from zone to zone instead of using solenoid valves, and they just cycle. Now, again, if they're installed correctly, they've got to be at the highest point in the system. Otherwise, they are not reliable. But if you can set them up to be at the highest point above all the zones, then I understand they work very reliably and well. I don't know about freezing conditions. Maybe people that have worked under freezing conditions can answer that. I don't know how well index valves, whether there is a risk of them freezing. I would imagine that there is. They need to be insulated under freezing conditions. Okay. You need to monitor the flow. It's very important from a maintenance point of view to make sure that the system isn't being overloaded. And, well, You just have to read the flow meter every visit and do the arithmetic, divide it by the number of days, and see whether it is within the design capacity. Typically, you'll be below 70% of the design capacity. Now, of course, if you're getting over 90% of design capacity, you're running into a risk level, and probably something is wrong. There's probably leaking toilets, or something's leaking, or there's 3 families in a single family home, or something's going on that shouldn't be going on. So that will need investigation. But that's very important in the maintenance, is to check the actual loading versus the design loading. And one of the problems is with multi-family systems is often the system is designed exactly to the actual historical usage when it's being fitted after, retrofitted. And then, of course, you've got no safety factor. So now, again, if it's a large number of homes, you're not going to get surges. It should stay fairly steady, and it should be okay. But if it does go up, you don't have that safety factor to handle it. But that's very important for the maintenance person to check the actual water consumption in the home, actual water consumption through the system per day is against the design. Okay. Now, pre-treatment, of course, has to be maintained. And this is, of course, up to the recommended practices of the pre-treatment manufacturer. We don't, obviously, make any recommendation on that, but they have to be maintained. If they're not maintained, well, obviously, the drip system, the filters are going to plug, and then, as I said, the homeowner can come along and take out the screen, and again, 5, 6, 7 years later, hey, the whole system's plugged up and I can't get it clean. Well, okay. Pump tank maintenance. Okay. The pump maintenance is talk to the pump manufacturer. Check with solids, as we spoke about before. Solids will build up at the bottom. And then, of course, also check your floats. Check the water level sensors. These are the floats, or if you've got some other type of water level sensor. Check the action of the floats. If you have an ultrasonic sensor, check it. If it's there's all types of sensors today, but I think there are sensors that are that measure pressure. There's one sensor that's quite popular, which lies down here, and it's measuring the pressure of the water, and those need cleaning periodically. So that should be checked. Remove the pump and check the inner screen. Check that it's clean, the inner screen on the pump, because the inner screen of the pump, of course, we are dealing with sewage, even if it has been through a treatment plant. And as I said earlier, it doesn't matter. There is no treatment plant, and I hope there's no treatment plant manufacturers getting into a fight with me, but there's no treatment plant in small systems that doesn't go wrong. Sometimes. And there's no treatment plant even for municipal systems that doesn't sometimes go wrong, as we read in the papers, as we read in the newspapers every day. Okay. Here's one that's gone wrong. This is real world. This is British Columbia. And this system ran for a year like this. At least we think it ran for the whole year like this. We're not quite sure when it went wrong, but it was a year between service calls. And this is what the maintenance person found at the end of the year. And if you... Okay, so obviously this is a treatment plant problem. So one has to go back and fix it. Okay, access issues. I mean, if you have something like this, you can't get in there. Look at it. I mean, everything's just too small to be able to get in. So make sure that, again, but this is a design issue. This is not a, let's see, this is dirt that's built up across the inside here, but it's also a design issue right from the beginning. Okay, this is the, remember I spoke about the biodisc filters. This filter was in this system. This was the pump tank that was supplying this filter. And this is the, believe it or not, this filter was still working. I mean, I found it hard to believe, but the filter actually was operating because the biological material did not manage to grow in between the discs. So that's why I'm so enthusiastic about this filter. Okay. Here's another filtration system with, here are the two filters. The other one picture we had, they were purple. In this case, they're black, but they're still disc filters. And this is the flow meter. And again, you need to clean these, and you need to check the 3 zone valves, 3 zone solenoid valves. Okay.
And actually, Rodney, I'm noticing a lot of insulation around this box. Is that a good idea too?
Well, I presume this is under freezing conditions, in which case it's a very good idea. If it's, yeah, I actually don't know where this box is. I don't know the system. But under freezing conditions, you definitely need to insulate the box. Okay, then a part of your maintenance is record the information on the control panel and write it down and check your operating pressures, and of course check your flows, which I presume is going to come up at the next slide. Okay, check the filtering system. Okay. Here's again, you take that apart, you disconnect it here. It's a easy disconnect. You can disconnect it there, you can disconnect it there, and you can take the whole filter out and you can clean it, or you can get the disc out, get the screen out and the disc out. The same here, he's taking out the bottom. The bottom there is being screwed off, and that is a disc in there, that's a disc filter in there. And here you notice he's got an air vacuum relief valve at the top. But he's unscrewing it, and this has to come out, and you've got to take it out, and you've got to separate the discs and clean them. And this applies, I mean, you're dealing with biologically active material, and even if the filter's working fine and the pressure drop across the filter's fine, I still recommend that at every O&M visit, whether it's biannual or annually, that be done. It is simple enough to do, and it's going to ensure good operation for the next year or 6 months. Okay, now here we've got one. This happens. This is the real world. Okay, I mean, obviously it's got to be dug up and cleaned up, but this is what happens. And this looks to me as though this was brought in by floodwater. But also what happens is that these headworks, some headworks have got bottoms, and some headworks don't have bottoms. You see, this headworks here doesn't have a bottom, and I think this one here before it, this one also, you can't see it, but that one also doesn't have a bottom. Most of them don't have bottoms. And if you don't have a bottom, you need to put, I would say, 12 inches of gravel underneath the headworks to ensure that you don't get dirt being brought up from underneath, and you don't have gophers. Because what that happens is, when you've got this in the ground, if one can imagine the ground level is here, and you've got a situation, I hope I'm drawing this a little better than it looks for me, like this, there's an open hole here and the gopher's running along here, and he's throwing up his mounds. Here he hits, oh boy, this is a beautiful, easy place to throw up his mounds because he's got very little resistance. And they throw their mound up in the box, and this is frequent. If you don't have gravel, if you don't put a good layer of gravel underneath there, there's a high risk of gophers throwing this up into the box. Now again, that's again part of the specification of the design is to put in gravel, also have a box with a, and here's another one, again with the same situation with the earth having been thrown up into the box. Okay. And here, believe it or not, it says it's a UV disinfection unit, so I believe it. Okay. I mean, so obviously the UV disinfection hasn't been working. Incidentally, again, and let me just talk about this for a few minutes. It's not on any of the slides, but let me talk about it. There's nothing wrong with UV disinfection. I mean, it's another layer of safety. If it's designed right and if the biological loading is right to the soil, is it necessary? In my opinion, I don't think so. Is it sometimes required by the regulatory requirements because of risk of contamination of drinking water? Well, okay, I'm not going to argue about the degree of risk aversion and the degree of safety that should be taken. It's hard to argue against being overcautious. But chlorine, excuse me, I don't like chlorine. It works, but chlorine is going to go through with the system. I'm talking about, continuous chlorine injection, or even periodic, unless it's absolutely necessary to, to clean out the system, and then it should be, once every couple of years. But continuous chlorine injection is going to go through and kill the bacteria in the soil. And the aerobic bacteria in the soil are our allies. These are our friends. These are the people that are consuming the anaerobic bacteria that are coming through. And I just think that it damages the natural treatment cycle in the soil. And if you like, you can talk to David Morgan more about that, as he's our soil scientist. Okay, now here's another one. This is a different one than the one we saw before. Another example, though, of a pump tank that doesn't look right. Okay, something's gone wrong before. I mean, this is why you need to maintain. This is why people need to come out and look. And as again, I would still argue for every 6 months, but even if it's once a year, it's better than not at all. Okay. Monitor your field zone flow rates. Each zone, you must look at the flow rate as against the original flow rate. The original flow, you must have good records. The original flow rate must be recorded, and then you check it zone by zone and check the flow rate. Okay. If there is a reduction in flow rate, it might indicate that we've got slime building up somewhere, or sand or anything. I mean, something might have got into the system and be plugging up the system. So you might have to use chlorine or acid, and there are chemicals that are available under extreme conditions. I had one situation, once in a lifetime sort of situation, I don't think will ever happen again, in which the farmer was a farmer and he was actually growing a crop which he was harvesting, which is fine. I mean, if it's not a root crop, I don't see any problem in growing oranges or any other crop of that type. And he took back guano as a fertilizer and added it to the pump tank. Well, I tell you, he plugged up that system like you can't believe. So, you know, you do get some freak situations like that, but they're very rare. As I said, that's only happened to me once. Check the field, walk the field, and if you have something like a gopher strike, or we had one where the kids pitched a tent on the drain field. It was a beautiful piece of grass, because of course the grass was growing beautifully under the drip line, and the children went out and pitched a tent out there and drove their tent poles through the drip line. I mean, these things happen. You'll see it straight away. I mean, there you get just such a large amount of flow. You'll see straight away, you'll see the water, and just dig down and put in a coupling. Okay. Check valves sometimes don't work right. So if you have an excess flow, it might be because your check valves being bypassed. They can fail. Either spring check or swing checks, both of them can fail, and often are check valves in the supply system. So if you have excess flow and you can't see it in the field, check your check valves. Okay. Landscape operation and maintenance. Okay. In the design, please encourage the people to keep their trees. Keep their trees, keep their vegetation. There is no reason not to go around or through the vegetation. This, of course, was done deliberately, and the drip line is straight down the middle here. And as I said, this is taking municipal effluent. It's a research project, but it's taking municipal effluent and it's growing eucalyptus. I think I called them poplars yesterday. Oh, I apologize. It's growing eucalyptus to be harvested for a pulp mill and to get rid of the effluent. Just as going as a interesting comment, irrelevant to the topic, but this is in New Zealand, and the Maoris have very, very strict laws about, very strict rules, I'd rather say, or customs about the use of effluent, the disposal of effluent, and they object strongly to treated effluent being discharged into the sea. Even it doesn't matter how well treated it is. I mean, you know, it can be tertiary treated, but they still object to that effluent going out into the bay. It's part of their culture. It's a cultural issue. And of course, they have tremendous political power in New Zealand. And the reason that this was done was in order to divert the sewage from the bay to the land disposal under pressure from the Maoris. So you said there's all sorts of peculiar circumstances that you do get, as I said, but even tertiary disinfected, they weren't allowed to go in, well, they object bitterly about it going into the bay. So, okay. Vegetation maintenance. Okay. Grass cover is always a good idea, or some cover, but grass is the most usual. It takes up the nutrients, takes up the nitrogen, takes up generally, well, it depends where you are, of course, but in the season, but during the growing season, it will take up all the nitrogen and take up some of the phosphorus. And of course, it provides evapotranspiration. If you mow it, the more you mow grass, the more vigorously it will grow. If you let the grass grow to a reasonable length, about an inch or two, and then keep mowing it at that reasonable growth, it will increase the evapotranspiration and increase the water take-up. Trees, of course, always help. Okay. I don't know how we're off for time.
Yeah,
okay,
you're fine, Rodney. You're only about, you're getting close to the end. your presentation,
Yes,
so
I'll
you're
just
fine.
dive
Go
in
ahead.
for 1 second. I'm going to ask a question here. This has got nothing to do with this particular topic, but it's relevant to our industry. People frequently, not when you're putting in a drip drain field, as I stressed earlier on, keep the trees, go through the trees, perfect. But most drain fields, you cannot allow trees anywhere near them. Particularly conventional drain fields, and drip is probably something like 1.5% of the market. So we've got the other 98.5% of the drain fields that go in. We can develop a barrier that could go around the tree that would prevent the roots of the tree from moving out of that barrier into the drain field. Obviously, those people that know of my company can have an idea of the technology we're talking about. Now, people don't need to plant a tree, but how often does it happen that the homeowner has got a beautiful tree, like here, there's trees here, and this is obviously a new house going up. And if a conventional drain field was going in here, the contractor will be required to pull out these trees. How often would the homeowner really like to see that the conventional drain field can still go in and the trees can be allowed to stay because they've been effectively shielded for a period of at least 30 years from the drain field? Is there a demand for that? Should we bother to market a product of that type? And maybe if this is a marketing survey, am I allowed to do this, Dendra?
Oh, absolutely. And interestingly enough, there was an article in On-Site Installer last month about efforts to save trees during regular installation, how damaging, even though you think you've avoided them, just damaging some of the main roots will ensure that the tree is going to die anyway in a very short space of time, or at least within, a measurable time. So it might be a false economy to try and save that tree at the time. And it's very sad because people do buy property or develop property for its location and its landscaping. So yeah, I'm seeing a reply coming back in for Dan that said, big demand, root treatment is a huge problem. Yes, it is. And if you've ever seen a tank opened up and the roots literally push their way out through the tank top, it's something to behold. So.
But generally trees are removed. Is that correct?
Yes. Yes, but just from personal experience, when we replaced our system, probably 10 years ago now, we had a huge maple at the front of the house in the front yard, and the main root system for that went clear underneath the house, out the backyard, and disappeared into the back garden. So never underestimate the capacity of a tree to go in search of water. So
yeah, there's no question. This depends on the tree.
Yeah.
You need your horticulturalist to know your tree. Yeah. But there's a question there about the cost. It won't be that cheap because you have to go at least 5 foot down. 60 inch, I'm thinking of a 60-inch barrier is what I'm thinking of, 5 foot down. And again, it's usually a sort of specimen tree you want to defend, and you've probably got something like, a 20-foot diameter. So we're talking about 20 feet and pi times 20 is, let's say 60, make it easy, multiply by 3, 60 feet round and 5 feet deep, so you've got 300 square foot of barrier.
Well, let's talk about that for another time, and just so we don't start losing people who have to leave by 1 o'clock. But go ahead.
But I gather that this is a real concern. Good. Well, maybe within 12 months we'll put something out to handle that. Okay, winter care. It's a good idea to have, particularly in cold climates, to have something growing over the drain field. We want to collect snow. Snow is the best barrier. Whenever we have problems of freezing, and happily we haven't had any for several years, as people seem to have learned how to handle it. But when we initially we did have some problems when people first started doing drip in the freezing conditions. It's when there's no snow. Take a year with no snow, and that's when the problems arise. So grass is a great idea. Check the fields for surfacing. Okay, this we spoke about. Repair broken lines, inspect air relief valves, and this we've spoken about. Alarms. Now again, the alarms can either be in the bedroom or outside, or in the maintenance man's bedroom if it's a Malibu home. And this depends completely on how much money's been spent on the control system and the alarm system, and the needs of the regulators and the needs of the homeowner. Okay, operation and maintenance is what is the secret. I mean, any system is going to break down if it hasn't got regular maintenance. It doesn't matter what it is. I mean, it might run for 5 years, as we've had systems that have run for 5 years before we get the call. Desperate homeowner who doesn't know who put the system in, doesn't know who built it, just saw our phone number on the panel. It happens too often. Not daily, but it happens really too often. Monitoring the zone flow rates and pressures, critical to get detection of the problem before it happens. Vegetation is always a very good idea. Certainly is going to help the performance in the field. Okay. Filter and field flush frequencies. Okay, we recommend 6 months, as I said. We're not going to fight with people if you do it every year, particularly if you make sure it's done every year. to say 6 months and have it done every 5 years doesn't help us. So, you know, if you say every year and enforce every year, it's better than that. Automatic field flush every 50 to 100 cycles is the minimum. Is that excessive? Yes. Does it cost anything to do it excessively? No. The amount of energy used to flush is so small that it really doesn't matter. I mean, if you flush once a week, 50 times a year, or 100 times a year, the difference of cost is insignificant. Manual filter flush every 6 months. If you don't have automation, I think that you should not go over 6 months before maintenance cycles. If you're fully automated, then of course a year is a lot easier to. And the filter flush is usually set up every pump cycle. Again, it doesn't cost anything. The cost is comparatively small. So if you have an upset and a pile of rubbish comes through accidentally, you know, then just get rid of it straight away. There's no point in not doing it. As I say, the cost is virtually zero. I mean, you know, if you want to argue that your solenoid valves are going to fail quicker, yes, they will. Okay, but so instead of lasting 20 years, they'll last 10. But I mean, it's not a. Okay, continuous flush. Okay, we've got a lot of people here from Washington, and Richard Benson is here, and Richard Benson knows my arguments very, very well. Okay. The advantages of continuous flush are only, in my opinion, lower capital cost. They are cheaper to build. The disadvantages are higher operating cost. Now, there's a considerable increase in the electric power consumption, because when you've got, you know, when you're pumping water, the amount of power you're consuming is at least proportional to the amount of water you're pumping. So there's considerably higher electric power consumption. you're going to have more frequent pumping of the pump, cleaning of the pump tank, and more frequent cleaning of the filter. So you're offsetting the advantage of the lower capital cost, which might get you the job from the customer, and is paid for over the long run with electricity and maintenance. We do have a situation where, unfortunately, where you have builders who are not homeowners, who are building to sell, and they've only got a one-year responsibility, and they will sometimes do anything to reduce capital expense, will buy the cheapest thing that will work for a year, and they leave it to the homeowner to carry the higher electricity costs, that happens. If it's explained to a homeowner the pros and cons, I would think that most homeowners will go for solenoid valve flushing. The higher the velocity at which you flush, some people flush at 2 feet per second, you're going to have 4 times more excess flush water than if you flush at half a foot a second. So again, at 2 feet per second, you'll be using a lot more electricity than at half a foot a second. Okay, so in my opinion, continuous flush will reduce capital expense. The engineer has to be careful to do the design with a minimum flush flow and large pipe sizes to ensure that the operating expense does not rise excessively, to see that the trade-off isn't excessive. And again, if he's careful and does it right, it works. I'm not for one moment saying it won't work. It does work, and it's a trade-off that should be carefully considered by the engineer. Is this a matter for regulators? I don't know. This is a regulatory decision as to whether regulators' duty is to defend homeowners from people cutting costs with resulting in longer-term operating expenses without telling them. I don't know. This is an issue that I'm not going to get into. Okay. Activate the pump and open the return line and flush each zone for at least 5 minutes. And we've got 5 minutes. You really want to flush anything out of the, that might have got into the system. So if you flush for 5 minutes, you'll really clean the zone, and do it zone by zone, obviously. Okay, reset the return line valve to its original setting. Okay, because it might be that the valve is being cracked open. It might be a manual valve that's being cracked open for continuous flushing. And check the field pressures, and that they're now back to the right pressure. Because if you're cracking open your return valve, you can, if it's too wide open, you're going to have your field pressure drop too low. And check your flow rate. Okay, walk the field. Nothing like walking the field. Check your vacuum breakers, as we spoke about. Replace filter screens or discs. Check if the pump tank needs cleaning. Record everything. The date, the counters, I don't know what ETM is. It doesn't matter. Fuel pressures and etc. Reset your control system for automatic operation. Electric solenoid valves should be removed and disassembled. Okay, every 2 to 3 years to ensure long life and continued operation. They do get dirt under the rubber diaphragm. Valves on primary effluent systems should be removed every year. Okay. Check valves in these systems are primary effluent. This is primary effluent. Check valves on these systems should also be cleaned with primary effluent. Okay, freezing precautions. Well, we've spoken about this. These two websites, which I see Brenda has put up already, are on our website, and they give you an excellent guide on how to design for freezing conditions. All right, well, as I showed a slide of a patent from 1888, a US patent of 1888, well, subsurface drip also isn't new. This is from the Pharaohs when they used to bury earthen pitchers in the desert and fill them with water. I've got no record of them ever filling them with sewage, but anyway, I have an idea that would plug up the earthen pitcher. But they were doing subsurface drip way back then. There's nothing new in the idea. And we'll move forward 600 years from the Pharaohs. And here I'm standing in a 200-year-old toilet with running water. Underneath there, this is obviously a communal toilet. I don't know what it's like when you've got a large number of people sitting around it. But this is a communal toilet, and underneath there, not there, that's a drainage, underneath this toilet, there actually is a stream flowing. And it flows out through a pipe into the field. So I tried to get to follow it, but I couldn't get to the end. And this is a 2,000-year-old running toilet. Ephesus is now in Turkey. It was part of Greece at the time this was built. It was part of the Greek Empire, let's say. Okay, well, thank you, everybody. I appreciate your attention and questions. And I see there's a question there.
Yes, it's from Janice Hoyer. Sorry. I'd really like to look at the agricultural application experiments that Rodney referred to regarding high BOD.
Yes.
Can you include the reference in the follow-up? Thank you. Very nice. Well, yes, thank you. And we'll make sure that we get that to you. You move on. And this is our closing slide here. I hope that we've answered some of your questions. If you would like a session that is in much more detail, do let us know. We'll be happy to set that up with Rodney. A reminder that coming up as soon as David is available, we are going to host an in-depth, and I'm not sure how long this is going to be, but usually it's an hour-and-a-half to a 3-hour session, so we may break it into 2. Specifically on soil suitability for subsurface drip dispersal. There, I said it without lisping or losing my way there. A reminder that there is a text transcript available, but send me an email, be happy to get that to you. And a reminder that today's presentation was underwritten in part by Geoflow as a service to the regulatory community. But if you are attending from an engineering firm or as an independent interested party and installer, we are requesting that you consider a free will donation to our organization. We are a nonprofit, and we do rely upon the goodwill of the general public to be able to do our work and bring you events like this. And at this point, I am going to stop the recording, but we will stay in the room for a little while here and take more questions. And if you have an audio or a video feed, please turn them on as soon as you hear the recording stop. Goodbye, everybody, but do stick around if you have more questions.